What browser are you using? Bummer. That was supposed to fix it. I don't have an answer for you. I'm sorry. What I would suggest is try to go by and see Mr. Cornish, maybe even second period, go by and let him get Chrome on there for you, and I bet it'll work fine with Chrome. I mean, that's a workaround, but okay. As I told you yesterday, everything that we're tying together, or today is where things, I think, really start coming together a little bit more for us, okay? By the end of this, which may happen today, it may happen tomorrow, we've got a lot of tools in our arsenal to figure out a lot of things about functions, okay? And then by Thanksgiving, we will be able to use all of that in more real-life applications, similar but different to the related rates now. So a lot of positive things, probably a lot of things as we look into optimization later on that you'll be able to see a lot more real-life applications for. So we're on 19, the first derivative test, and look at this graph here. I gave you the function. I gave you a graph of the function. Where is this function increasing? From x being what to what? You've got it on your paper there. It may be easier to count on there. Okay, so we're going to say it's increasing from negative infinity to what? Really? Or negative 2. Negative 2, okay? Now, notice how I wrote that. I wrote that with open parentheses. Why did I use open parentheses instead of square brackets? That's right. At negative 2, it's not really increasing. All right? Is there anywhere else that this function is increasing? 0 to infinity, okay? Where is this function decreasing? Negative 2 to 0. Now I want us to stop and look at something right here. Do you see any, okay, do you see anything, thank you ma'am, that is special about the numbers that we wrote in there? Negative 2 and 0? When you look at the function, do you see anything special about these places right here, negative 2 and 0? They're critical points. Negative 2 and 0 are critical points. Now somebody remind me what critical points are. That's right. That means that the first derivative is 0 or it's undefined. So the function changes from increasing to decreasing at critical points. Okay? That's a pretty significant thing to know. The function changes from increasing to decreasing at critical points. So let's just make that statement, write that statement down. A function, and we're going to generalize it, changes from increasing to decreasing at critical points, CP. Does it have to change? Does a function, and you can't just look at this one up here, but think about functions. Does a function have to change directions? Does it have to change from increasing to decreasing at a critical point? Is it possible for a function to have a critical point and be increasing and then increasing again? It is possible? Can you come draw one for us, Sherry? You can, let's scroll down the page a little bit. There we go. Where's the critical point? I don't think the derivative is 0 there. For it to be a critical point? Yeah. Say that again. The derivative has to be 0 or undefined to be a critical point. So how can it have a critical point? How can it have a critical point? Do y'all think does that meet the criteria? Because, very good. Thank you, sir. The critical point here, what's true at this point right here, Jamie Lee? What's true of the derivative there at that point? Undefined. F prime is undefined. Okay? So it's easy to see that if F prime is undefined, it could be increasing, undefined, and then increasing. Could it be 0? Very good. Okay. Thank you, ma'am. So at this point, right along in here somewhere, F prime is 0, but the function's increasing on both sides. Now, here's a trick question. Think about this, okay? Let's say we've got this, and maybe that is -4, and this is 7. On what interval is the function increasing? Or what interval, parentheses S, is the function increasing? What? Yes. It's not in, this is not correct. All reals is not correct. That function is not increasing everywhere. This is not correct here. Increasing from -4 to 7 is not correct because it's not increasing everywhere there. You've got to say either that it's increasing. You could say that it's increasing from -4 to 0, assuming that's 0 there, okay? And 0 to 7. You could say it's increasing for all x except 0. That upside down A means for all, except x equals 0. Either of those you could say, okay? But it's wrong to say it's increasing everywhere. That's wrong. Okay? So suddenly, critical points tell us that, hey, the functions could be increasing and could be decreasing on sides of it. Let me ask you this. Could the function change from increasing to decreasing at a point that's not a critical point? Is there a way for the function to be going up and then down and not have a critical point? How? Come on. Okay? Okay? So, no. Oh, because the function is increasing all the time, isn't it? Well, but draw that again. Draw it almost again. Now, the function changes from increasing to decreasing, right? Is this a critical point? Very good. What is that? Critical points only talk about when the function is continuous and defined. The function is not defined at this point, is it? Because this is an asymptote. So that's an example where it goes from increasing to decreasing, but the functions are not actually defined here. The only time that a function can go from increasing to decreasing is at a critical point. Okay? So that's an important piece of information to know. If a function is going from increasing to decreasing, it's got to happen at a critical point. What else happens at critical points sometimes? What have we been talking about? We use the critical points to determine what? On the quizzes. Max and mins. So, listen to what we just said now. At critical points, it's where a function could change from increasing to decreasing or decreasing to increasing. Critical points are where maxes or mins could occur. Is there a relationship between the function increasing and then decreasing and maxes and mins? Do y'all understand what I just asked? Is there a relationship? Let me write it down so maybe I can say it. Is there a relationship between f increasing and decreasing and max and mins? Did y'all hear what she said? I'm going to write up here. She said if f increases and then decreases, think about what that looks like. It increases and then it decreases. What's that? Then the max. And we need to clean this up, but we're just trying to write quickly here. What if f decreases and then increases? Then it's a what? A min. What if it increases and then increases? What if the function increases and then increases? Is it a max or is it a min? It's neither one. What if it decreases and then decreases? Neither one. So only if it changes from increasing to decreasing, if it changes from increasing to decreasing, then it's a max. If it changes from decreasing to increasing, then it's a min. Well, that's easy to see on this picture up here, isn't it? But what if we didn't have the picture? How could you figure out where the function's increasing if you didn't have the picture? The first derivative test. Very good. But how? What is the first derivative test then without looking forward? All right, let's look at something here. I want us to look at where the function we said is increasing. We said the function's increasing here and here, right? Can you tell me anything about the first derivative on those two areas? First derivative is positive, right? Would you agree that in both of these places, f prime is greater than 0? Well, let's see if we can take that a step further. What's happening in here? It's decreasing, right? And what's true there? F prime is less than 0. So suddenly, your derivative tells you a lot of information about where the function is going, about whether the function's increasing or decreasing. Do you agree? So let's see if we can put all of this together with something that we've never seen before and work this out, okay? So skip to this page right here for me, okay? Which is probably your next page, if I'm guessing. Now, the instructions say, without graphing, find the intervals on which the following function is increasing and decreasing. Now, what did we just say that we could use to figure out where it's increasing and decreasing? Critical points and the derivative, okay? So here's what we want to do first. This is going to be kind of an outline of what you want to do. Find f prime and set it equal to 0. All right? So take the derivative of that function, set it equal to 0, and solve. I bet you're smart enough to do that. I hope you're smart enough to do that. Find the derivative, set it equal to 0, and solve. That is a negative sign right here, by the way. It's a negative 2x cubed. Mr. Bowman, what's the derivative of this creature here? Negative 6x squared plus 6. So we're going to take that derivative, set it equal to 0. All right. Terry, what do you think we should do to solve that now? Divide by 6, and we get negative x squared plus 1 equals 0. Huh? 6 or negative 6? 6 or negative 6, either one. Doesn't really matter. Okay, I'll buy that. So we've got negative x squared plus 1. What do we want to do now, people? Anyone? Subtract the 1, so we get negative x squared equals negative 1. So we get x squared equals 1. So we get x equals plus and minus 1. What have we just found? These are critical points, okay? These are critical points. Bless you. All right? Now, what do we know is true at the critical points about the function? We know the derivative is 0. What is the function doing there? It's changing from increasing to decreasing or decreasing to increasing, or it could be changing. We know it's kind of flattening out. It's taking a rest at those places. So here's what we want to do now, okay? Second thing we want to do. Make a sign line for f prime. Y'all remember sign lines? Remember us talking about those creatures? Now remember our f prime was negative 6x squared plus 6. All right? Well, we found out that that derivative is equal to 0 at negative 1 and 1. So we're just going to put those 2 points on there. That's why the derivative is equal to 0. We need to write out what are the factors of negative 6x squared plus 6. What multiplies together to give us that number there? How do we figure that out? Well, if we go back up here to our work, we divided, but we could have really just said we factored out a 6, couldn't we? And we can factor this thing here. So we could factor this as, I'm going to factor it this way, negative 6x plus 1, x minus 1. Now it's important that you have all 3 factors there, okay? Negative 6, x plus 1, and x minus 1. Does everybody see how I got to this? Factored out a negative 6, and then I'm left with x squared minus 1, so I factored. So I'm going to come down here to my sign line. I've got negative 6. I've got x plus 1. I've got x minus 1. What do we do now? You remember? Pick a number to the left of negative 1. It doesn't matter what numbers. A number to the left of negative 1. Is this factor positive or negative when x is negative 7? Is this one, the second one down, is it positive or negative when x is negative 7? And what about this one when x is negative 7? So negative times negative times negative tells us what? It's what? Y'all say it. Yes. Negative. What does that tell us about f, the function? If this says that f prime is negative here, what does it mean if f prime is negative? The function's decreasing. Therefore, we know f is decreasing on this interval here. Okay? We know f is decreasing. Let's write that so we can actually read it. F is decreasing. Okay? We're going to go through the same process for a number between negative 1 and 1. So when x is 0, is this first one positive or negative? Negative. When x is 0, what about the next one? And the next one? So that means that the whole derivative is what? Negative times negative makes it a positive. What does that mean f is doing in here? What's f doing in here? It's increasing. Okay? And then if we do the same thing over here at a number bigger than 2, bigger than 1, negative 6 is still negative. 2 plus 1 is positive. 2 minus 1 is positive. So the whole derivative is negative. So what is f doing over here? It's going down. Are y'all with me there? So where is the local maximum? At 0, why 0? Where is the local max? Where is the local min? Say that again. 0 and 1. Why 0 and 1? Oh, you're saying when x is 0, 1 and where's the max at? Josh, you're saying there's a max where?
1.
Max at 1. Oh, over here. Max at 1. Why is he saying there's a max at 1?
Because it gets from positive.
That's right. Think about what this function's looking like here. We said the function's going up in here. We said the derivative is 0 right here. We said the function's going down over here. So that means this has to be a max. Would you agree? What about over here? The function is, what's going to be happening here? At -1. The function's going down. The function is 0. And after that, the function's going up. So what about this point here? It is a min. Okay? Min at -1. So suddenly you can figure out where the maxes and mins occur by using the first derivative test. That's what we just did. The first derivative test says take the derivative, set it equal to 0, do a sign line, and determine where the maxes and the mins occur. Okay? All right, let's think about, we said that this means the fact that the first derivative is negative means that the function is decreasing. So a decreasing function looks like it's going down, right? At -1, we knew the derivative was 0. What does that mean it looks like? So that means when we get to a -1, it's got to get flat. F is increasing. That means the function's going up. So it went down. It was 0. Then it had to go up. So this point has to be a minimum. If we're looking at it from here over, F is going up. Here, we said the derivative is 0, so it becomes that. Then the derivative goes back down. So that means this point has to be a max. Yes, ma'am?
By doing a sign line, are we basically just taking the limit?
No, we're not really taking the limit. We're determining what the sign, S-I-G-N, of the derivative in here. Let me ask you this. How do I know that the derivative is always positive between -1 and 1? How do I know it's not negative somewhere? I mean, we just tested one point. How can I know for sure that it's only positive between -1 and 1? For all the points? That's a lot of points. You'll never get finished. What about the critical points? The critical points are here and here. So you're saying it can't change from positive to negative without going through a critical point? Would y'all agree with that? So we know these are the only places that the derivative is 0. The only places it can happen. So between these 2 points, the derivative's got to stay the same sign all the time. It's got to stay positive or it's got to stay negative. Same thing over here. We know there's not another critical point out here, so the derivative has to stay negative. So we have a good general idea of what this graph looks like. Does this graph look just like this? Do we know where this point is? Do we know where this point is? We don't know any of that. But we have a general idea of what the graph looks like. We know this is a minimum. We know this is a maximum. And we got all of that by taking the first derivative of something, setting it equal to 0, and doing a sign line with it. Let's look at, yes, ma'am?
Isn't it the same as like evaluating the limit of like x, which is -1 from the left, and then -1 from the right?
Well, but the limit of f is only going to be zeroing in on the actual value of it. It's taking because it's the derivative, it is taking the limit, because remember, derivative is taking that ugly limit. So we are taking the derivative. We are evaluating a limit, but we're not going through the limit process to do that. Oh, no, I've just killed it again. See, I told you, I've killed it. I've killed it. Okay. So, in summary, I've killed it and gone forward. In summary, let's look at this slide and see if any of this makes any sense. In summary, if f prime is positive, then the function's increasing. If f prime is negative, then the function is decreasing. And we can use that to find out whether it's whether the function has a max or min at that particular point. Okay? Let's try another one. I know you don't want to, but let's do it anyway. Okay? Find out where the max and min occur for this function. Or let's just use the directions. Find out where the function's increasing and decreasing. Tell me how you're going to do that, okay? Then we'll let you go. How do I find out where the function's increasing and decreasing? Critical points. How do we find critical points? F prime equals 0. Go. See what you can come up with. There it is. Y'all have it. So I'm going to clean up the rest of my notes while y'all are doing that.
No, you never do the box method. Never. The quadratic formula
Teachers, please remember if you are able to, please escort your students out between the athletic field and school building to send off the softball.
Oh, I forgot. We're supposed to go send off the softball team. Okay? Stop what you're doing and let's go send off the softball team. My apologies.